notes. This top part is a gentle reminder. Going up is positive, going down is negative. A horizontal line is going to have a slope of 0. Okay, so that's like the ground floor that you're walking on. A vertical line is going to have a slope of undefined. Okay, so that's like a wall going up. The slope movement is a vertical change or a horizontal change, or rise over run, up over, or y over x. Okay, it's really the change in y over the change in x. That triangle there tells you that it's the change of. So remember on whenever last notes, we talked about our slope formula, which was y2 minus y1 over x2 minus x1. Okay, that's all this says right here, the change in y over the change in x. Okay, when we talk about Mr. Slope Guy, you've probably seen him before. You know, you draw your eyebrows and that tells you whether it's positive or negative. The nose tells you that it's undefined, the line straight across, and the like little dimples or cheeks tells you it's a 0 slope. Okay, so that's all just a reminder. Now, when we're talking about slope of a graph, okay, you're just looking for the change in y for the change in x. How much do I rise? How much do I run? Y'all are honors kids, I get that. I'm going to teach it to you like I teach it to my regular kids because I want to make sure that we understand it for at least the first couple, okay? So I always get 2 different colors, and I go to my first point, and I'm going to draw a straight line down, okay, or a straight line up to where I know the other point is. And then I'm going to draw a line straight across to intersect that line. Okay. And this is what I do, at least at the beginning, just to make sure that I know what I'm doing. So then I go and I start at one point, and I see how much do I rise until I get to that intersection. Well, I rise 1. Okay, so for line A, I rise 1. And then how much do I run? I run 3. Can 1 over 3 reduce?
Yeah.
No. So that's my slope. Okay, because that's line A, my slope is 1 over 3. That's it. Okay, I always just do the lines as the intersections to try to make sure I know that I'm going to the right points. So when I'm looking at line B, also is this a positive or a negative slope? Positive. Just got to make sure. Okay, line B, same thing. I'm going to draw a line up. I'm just going to kind of stop short because I know where my line is and draw a line across. And I do the same thing. How much do I rise? How much do I run? And I just count it by going from each little kind of box or bump. So I rise 3. I run 3. Does that reduce?
Yes.
To what?
1.
To 1. Is it a positive or negative slope?
Positive.
Positive, so there's my slope. Any questions?
No.
Would you guys like me to continue doing the lines across, or do you just want me to count them with you?
I think we got it.
Okay, so I'm just going to count them with you. Okay, so if we look at line C, I rise how many?
4.
4. How much do I run?
3.
So I've got 4 over 3. Is it positive or negative?
Positive.
Does it reduce?
Yes. No, it doesn't.
No, we leave it in an improper fraction. I think I heard somebody over there say 1 1/3, leave it improper. Okay, line D. How much do I rise?
4.
4. How much do I run? 1. Is it positive or negative?
Negative.
Does negative 4 over 1 reduce?
4.
So negative 4. Perfect. Any questions?
No.
Okay, line E. It's this line right here. What's my slope of that line? Undefined. I'm just going to put UND, undefined. Okay, and line F, how much do I rise?
2.
2. How much do I run?
6.
Does that reduce?
Yes.
Is it positive or negative?
Negative.
So it reduces to negative 1/3. What about line G? What's my slope?
0.
0. Now line H doesn't have 2 points, so you have to find 2 points. So I'm going to find where there's an intersection. It looks like there's an intersection there and there. So how much do I rise?
4.
2.
2.
How much do I run?
1.
1. Is it positive or negative?
Positive.
And it reduces to? Okay, now you could have gotten, you rise 4 and then you run 2, okay? That works the same way. Any questions over how to find a slope from a graph? Okay, so let's look at how to find a slope from a table. So I picked 2 points and use it as a slope formula. So it doesn't matter which 2 points that you choose from your table. You can choose the first 2, you can choose the last 2, you can choose any of the points, okay? I always just like choosing the first 2. So remember when we were doing this with just regular points, I would label them x1, y1, x2, y2. I do the same thing just to not get myself mixed up. And then I plug it into my formula that we have. So we do y2, which is negative 1, minus my y1, which is negative 3, over x2, which is 0, minus x1, which is negative 4. And 2 negatives do what?
Make it a positive.
Make this a positive. So these are really negative 1 plus 3 is 2 over 0 plus 4, which is 4. Does 2 over 4 reduce to what? 1/2. Questions? Now, when we have a graph like this, or a table like this, remember it's x over y. Okay? So I've got my x1, x2, y1, y2. So I've got 60 minus 40 over 4 minus 2. 60 minus 40 is? 4 minus 2 is? Reduce that?
No.
10.
1.
Or just 10? Okay. Are there any questions with slopes from a table? Okay, so then let's turn over to the back. Okay, so direct variation and directly proportional kind of mean the same thing. Okay, there's only one thing different about direct variation, but we'll go into it in a couple of days. So, if y is directly proportional to x and y equals 3.5 when x equals 7, what is the value of x when y equals 8? Okay, so remember on the other side we talked about it's really like y over x. Okay, we can do the same thing here because we know they're directly proportional. It tells us. Okay, so they're going to end up being equal to each other. So I can say that 3.5 my y over my x is equal to my 8 over my x. Okay, and you've done this before. We just don't call it the same method because directly proportional is the method that we use. But y'all know it as we're going to do the butterfly.
Okay.
So you multiply here and you multiply here. So I get, this is now 3.5x equals 56, and I just solve for x. So how would I do that? Divide by 3.5. So 56 divided by 3.5 is 16. And that's it. You will have some more problems like this, but I figured this was just a reminder that you needed on how to do it since we've done this before. Any questions? Okay, so the last part is slope as a rate of change from graph and equations. Okay, specifically from graphs. So when I'm looking at this first graph, okay, it doesn't have points. Most of the time they're not going to have points. You're going to have to find your points. So remember, that's when any of your lines going across here, when they meet at a point, okay? So if I just found 2 points here, what's the rise?
1.
What's my run? So what's my rate of change?
1.
It's really going to be like 1/1, which equals 1. Remember, rate of change and slope, they mean the same thing, okay? And then, I don't know why it says, what do you think the 20 on the y-axis represents, because there's not a 20. But if we put a 20 here, what would the 20 represent? Do you remember?
Starting at money.
The y-intercept, okay? So the 20 in our case would be our y-intercept, okay? I don't know why the thing didn't follow, but we're going with it, right? Okay, let's look at problem number 2. Okay, so I find 2 points. I see I've got a point here and maybe a point up here. So what's my rise?
2.
Look at that again.
Oh,
It's what?
30.
It's 30. Okay, pay attention to your x and y axis, what they're worth. Okay, so each of these lines is really 15, so my rise is 30. What's my run?
6.
6. So my rate of change would be 30 over 6, which gets me
5.
5. Okay, so this function represents a direct variation because the graph goes through the origin. Okay, anytime you have a direct variation, it goes through the origin. And then what do you think the equation for the line would be?
Y plus B.
Y equals mx plus b is what we need to put it in. So what's my m?
0.
It's my slope or my rate of change, which is 5. And then what's my b?
Y-intercept,
Which is what?
0.
Do I need to write that down?
No.
Perfect, so there's my equation. Are there any questions?